Hello, hello, hello. Welcome to the ShipTalk podcast. Today is season finale of our season three, and we have a very special guest with us, Puneet. Puneet is the VP of Engineering at Harness. Welcome, Puneet.
Yeah, thanks, Dewan. Excited to be here. Uh,
Likewise, super excited. I like the swag you have on you.
yeah, we have the same. I think we both bleeding harness today.
Yes, yes, yes. I know you mentioned it's pretty warm in the office, so I appreciate the dedication to put on the swag.
Yeah, like when I started, it was all cloudy, and then now I see it's kind of all sunny. That's Bay Area for you. But yeah, I love the swag. I have been at Harness for 7 years, so we get so much swags, and it's kind of the joke in the office. Like every day you can repeat, you can have Harness swag and don't repeat. Like so. Uh, yeah, but that's kind of life, Harness.
Yeah, yeah, absolutely. And I have the same. My wardrobe is full of IBM, Red Hat, Ivan, and now Harness. So from socks to t-shirts to hoodies, I have a backpack, I have a luggage. So I have to actually find like where I don't have a water bottle. So I have to now find out where I don't have a swag on a product, and then probably like get that
Yeah.
next time.
And maybe you're aware of it. We have this Life at Harness Slack channel, and where people, go on vacations, and they'll like all kind of exotic places. They'll put like Harness bottle for and the swag there, and like Harness has been there. So I see like so much company pride in the team there, and swag goes a long way building that.
Absolutely. And I can already sense the passion you have for the company and for engineering. But we want to learn where that passion first started. Like where did the passion for engineering or problem solving start? Was it at IIT? Was it way back before then? Would you guide our listeners to your journey into tech?
Yeah, I think the so my journey started like very early. So in the school, I think it started like seventh or eighth grade when I got to use the computer for the first time, and that was like in the lab we had in our school, and that used to be like one of the and like I come from India, UP, so North India, so it's like a hot region. So the computer lab was one of the uh, that sought after place of rescue from the summer heat there. And that's where like all us kids will go there and be in the computer room and program, and we started programming with basic, and primary thing was, okay, this is the room you kind of escape from the heat. And like early, I found like the programming was like the kind of feedback you get, and instant feedback, and what you create, you can see the results of it. Like that gave me that kind of early interest in programming, right? Like that's where like on the summer, I remember in the eighth grade, took a summer project to build a school reporting system, which is like report card building system. And we programmed on basic with one another, other friend of mine, and it was super fun. So this whole ability to program and see the result and iterate, and that kind of hooked me up in tech. And of course, like IIT was a formative time. We can talk more about it, but like once I went into it, it's like very high caliber uh, people from all over India, come at one place, and like you have a lot of fun and learning, and so that kind of also cemented like next level of that's where I got into com science, did some AI machine learning. Those were that was like around more than 20 years ago. Like still we were doing uh, things like background segmentation, and my thesis in the final year thesis project was image segmentation of like moving parts of the bodies, and it was feature extraction on the images, and computer vision and machine learning intersection of that.
Well, and that was like way before there was a hype around machine learning and AI, and even in academia. Was it common for folks to to use AI and machine learning in projects back then?
No, it was not that popular, but it was coming along. It has not captured the public imagination, as you know. But in the academic circles, still machine learning, neural networks. There was no deep neural networks were not the thing, but we were learning. Artificial intelligence used to be the introductory course in IIT Kanpur, and there we would learn things like feature extraction. We would learn things like background segmentation from in the pictures, and uh, at that time, you used to use Matlab uh, and C, and the vision libraries were there. OpenGL had come, so they were like academia had uh, the action going on, but it had not like really become the thing which it became in like last 3 4 years.
You mentioning MATLAB is bringing my electrical engineering days where we had a induction motor hooked up and then we could run some simulations on MATLAB. And MATLAB was a beast of a program that you really need a pretty beefy machine to run MATLAB. And also things were not like these days where you can just mostly use open source and you can almost find a lot of free tools, especially in academia. You had a license and you had to go to the lab computer to use it. Was
Yeah,
it similar for you as well?
yeah, those were the fun days. Like we used to have this computer lab again in Kanpur was a super hot weathers, and then computer science department is the place where you get the respite from the heat, and we used to just flock into the in the department, and we used to have like this labs. Every prof will have their labs, and there'll be all the infrastructure available for you to hack around. So had these project like so MATLAB was like one we use for this image segmentation project. Uh, so we would say extract out the foreground object from the background. And I remember the first one was we got a video, a series of images from our TA, and he was walking around on the campus, shot this video, and our task was to segment him from the background, and then build that series of images through that segmentation. It was pretty fun project. Yeah, it used to be. Yeah, those are the days.
And I think we are aging ourselves with those references. So moving from IIT to Microsoft, you have spent a significant amount of time at Microsoft building secure and scalable systems. What were some of your key takeaways into building those production grade systems?
Yeah, I think Microsoft was my first job out of college, and the first day I remember, like I ended up in a team which was starting to build Windows 7. So Windows Vista project got over, and there was like all uh, reshuffling, rethinking happening for Windows 7 and Windows Vista. There was a lot of learnings Microsoft was applying on towards Windows 7, and that's where I got um, my first team located. And for first 3 4 years, I was just working on Windows kernel, building this networking device drivers. And that was a lot of fun. That's where like my training to production level systems happened. And you see like Windows that uh, was like the the operating system of the masses there. And uh, what I learned there is like there is no corner cases when you're building software for production system at that large scale. And there's uh, some interesting stories. And as we went to release the release preview of Windows 7, and then it went out, and the kind of components we had a pretty good telemetry system there, where on the wild, if there is a issue which happens on a machine, which if you're in kernel mode programming, that what you call blue screen of death or bug check systems. So Microsoft, we had a pretty good telemetry system where anything had those hit into those bug checks will report back to the system, and it'll route to the right developer of what things have happened. And I remember like those like sleepless nights and week after we released it to beta, where software has gone to the real users, where we were sifting through all the issues getting reported, and we invest days and weeks to understand root cause, fix them. We could see the whole life cycle of it. This The learning for me is, in those days, is there's no corner case. The reliability of system at that scale, what like everything which can go wrong will go wrong, right? So that's where we learned like attention to detail, building system which you can debug after the fact, and so. But those are the fun days.
You build a lot of reliable systems at those is scaled, but were there any instances where your team probably worked on some sort of scale, but you hit a bottleneck? Things didn't go as planned. Could you share any of those situations?
Yeah, I think all the time. I think the second stint for me at Microsoft was moving to the Azure team. So I in 2014, 2013, 2014 time, I moved to the Windows Azure team. Is still was called Windows Azure. Later it got branded to Azure, and Microsoft embraced non-Windows ecosystem, Linux ecosystem, very first class along the way. Uh, but that's where like the some of the unlearning and relearning happened for me in Azure, uh, where in say Windows we were releasing every 2.5 years, and the milestones used to be 6 months milestones, and your release vehicle is like you're shipping your uh, Windows bits, either CDs or people are downloading uh, the tarballs from internet. Now it was more like you're doing continuous deployments. Your delivery is to the cloud, and then you have more control, and that's where like a lot of distributed systems um, training came for me, and this whole new paradigm of your like delivery is different, the cloud delivery is different than like pre-cloud era. And we built the scale was like I was primarily looking into the control plane of some of the critical resources for Azure, and we had to go from regional to global footprint, and how do we isolate say one region from other. One project I remember was like, how do we have the blast radius of any fault limited to a given region. So what we learned is like you cannot take dependencies on a global dependency on a project or any resource. And how do you segment your traffic and your data within the region. What you could not explain is like if a fault in say US West region take down your service in which is running in Australia. All right. So uh, with that, like these days people call it cellular architecture. Uh, those days that term was not there, but it was more like how do you control the blast radius. And so those are the things where you see it inherently brings the scale. Like if you need more capacity, you just create another cell, which is like another region for you. uh, but you coming back to your question, like things which didn't scale, like all the time, like our APIs were not uh, scaling the way we were using synchronous APIs, and which were blocking the threads, and we had to kind of build this decoupled system where the queue got introduced, and services, a new API request will come, will register the request, and it will go in the queue, and then the workers will scale as the number of outstanding requests increase. And those are the early patterns which we started to learn and incorporate in our architecture.
I want to touch on this point because some of our listeners, they're still in their school. There might be final year of their engineering degrees, and they might be thinking, "Oh, I'm studying for my Java exam and these design patterns. Do I actually get to use it?" Yes, you do. As Puneet is mentioning about the fundamentals, fancy technologies come and go, but these fundamentals never change. Would you agree with that, Puneet?
Yeah, absolutely. And especially like now, there's so many building blocks of where and then architecture patterns which have emerged in last 10, 15 years. Uh, but yeah, like all these things matter at the internet scale technologies. Think of like how do you plan for the surge in the traffic? You cannot keep your capacity for the search. And the way you do it is you decouple from like your running systems from your request by introducing this concept of queues and workers. And then you have the flexibility of as the work is coming, the queue size increases and you can scale your workers accordingly. And that is like a pretty standard pattern which has come out in the distributed systems world and the cloud services now. Was not the case when we were doing Windows, like because when you're running Windows, you're limited by the hardware you are running on. So this thing is in the cloud era where your compute is like a lot more scalable. And how do you kind of use that compute capacity when you're not restricted to one system?
It seems like you had a pretty good run at Microsoft. You're understanding the systems. You are already pretty deep into your engineering career at Microsoft. Then what made you switch to Harness? Like, how did you hear about Harness and what was your why now moment?
Yeah, I think that's a interesting story. Like the time I was running this team in Azure, the team was called Application Gateway, and that's like serving all the like if you're uh, running HTTP workload in your virtual network, you put Application Gateway in front, and it gives you kind of SSL offload and routing capabilities at HTTP and WAF and all that good stuff. Um, and and we saw pretty solid growth, like it like last like 4 years we launched the service and we were running a fleet of like um, tens of thousands of virtual machines which are running these uh, load balancer systems. Uh, and it's still a small team which is operating it. So what I saw, like the operational part and the toil was real, like we had this cadence of bi-weekly releases for our gateways, and we had to roll it out across a fleet of like Azure regions, which were like dozens of regions those days. And you have to plan this whole activity every 2 weeks, and then deployment and patching and upgrades was like the part of the rhythm for a small team. By the time you're done with one, the second was already uh, upon us, and then if something happens wrong, and then you have to roll back, you kind of miss the cycle, and there was a lot of like operational toil and firefighting, and you can imagine like running this fleet of tens of thousands of virtual machines, keeping them updated, keeping them like monitoring them. And so I could see like we were there itself trying to build some systems to improve the operational aspect, which is primarily it was like deployments were a big challenge. Right. So when I uh, in 2017, when like Harness came out of stealth, and uh, I got in touch with Rishi, CTO that time, and he explained to me the problem they're trying to solve. And uh, I could identify like that was the problem I was living day in, day out at Azure that time. So I could see the potential of the idea and seemed like the problem is for everybody, not just like my team at Microsoft. And also I wanted to do something in the smaller setup. Startup was always is the thing. So that's the time I can decided to join the ship. Um, and we were very small that time. It was like January of 2018. I onboarded here. Like we were like around 15 engineers that time, few beta customers, and yeah, we were just hacking around. We were building the CD as our first product those days.
And the work you were doing, like when you joined Harness, how much it overlapped with the work you were doing at Microsoft? Like how much new stuff did you have to learn?
Yeah, it was completely new in a way. Like I was doing cloud infrastructure work. So it was still a layer. I was building the components which you use to build your applications, if you will. And there were some applications we were running in the control plane there. Uh, but what Harness was, Harness, where we were building this very distributed orchestration system, which you can do declarative pipelines, and we can help you build this advanced deployment strategies which you can implement with, like without going doing the grunt work of writing those like scripts, which used to be the norm people were doing before. So the work was primarily like the nature of work was different, but fundamental building blocks were not, like we were still building cloud services, we were deploying continuously, we were delivering through cloud SaaS models. So there were a lot of parallels, but I would say it's from the in Azure I was building the infrastructure services. Here it became more like a SaaS service for deployment.
So one level probably up.
Yes.
And so back then, team of 15 engineers. Now you're leading dozens, if not hundred of engineers. How does your day-to-day work uh, look now? So, for example, a VP of engineering, uh, how do you start your day? How do you end your day? What are some common things you do?
Yeah, I think as teams evolve, like you tend to build like multiple teams and which you are running and which are aligned for different part of the business. So at this point, I'm running the platform engineering team and SRE team at Harness. And so the way our like day starts is like, okay, like a lot of work here is like strategy and doing the alignment for what is team working on and how like business uh, is aligned to that. So a lot of work is around that, like how we plan, what projects to pick. Are these the projects which are kind of moving the needle in right direction? A lot of work is like, is there cross team collaboration happening? These like we are building on each other's ideas versus reinventing the same thing in multiple places. That's kind of what we do in, especially in the platform teams. You build the core technology, so the teams using you can leverage it versus like they have to build their own and reinvent the wheel and uh, waste the efforts there. So a lot of work is about understanding this internal stakeholders, understanding what their needs will be, solve them today, uh, versus they are able to capitalize and accelerate on their delivery velocity. Also, other part of it is like also I have good fortune to run like say platform engineering. So think of this as a meta problem for Harness. Harness is a platform for platform engineers or DevOps people, and running that part for internal Harness teams. So we are running our own, like if you will, instance of Harness, which we from our own code repositories to our own CI system to CD systems to all the code to production. What we enable our customers, we are using Harness to do it for building Harness itself. So a lot of the things are like what we are building. We are the first user of it, and then we have that front wave row seat of like what to build as a user in the product. Right. So a lot of work comes in, like seeing what's working, doubling down on that, seeing the alignment across teams, making sure we are doing the right things for the business.
Harness is known as the AI native software delivery platform. So you mentioned about scale, you mentioned about security. How are you solving the challenge of adding AI and automation into this software delivery platform?
Yeah, I think like you can't do things without the AI anymore. Like there's so much uh, shift coming, and with the capabilities of agentic AI now. So think of like the way we think about it is like with this agents available at your fingertips, how can you make developers more productive? How do we streamline code to production path? Still, there is a lot of like time, which estimates is like less than 40% of the time for a developer goes in actual coding, and there's a lot of uh, innovation happening in the coding side of things with the co-pilots and cursors and windsurf. And what we are looking at is after the code is done, for the code to be available in production, is still there is a lot of process and toil involved in the system. And what we are thinking about is with like harness becoming is that platform which has all kind of tools available to help you in that life cycle of code to production. The next unlock in that will be like how can this agentic AI or AI agents are going to take away some of the work which we're doing today. You're still triggering the pipeline. If the pipeline are failing for one reason or other, can agents work through it, automatically remediate, uh, or help you understand, debug if there are security scans in your pipeline and you're finding vulnerabilities? Can agents go proactively figure out the remediation and make it for you? Uh, if right, like so, those are the kind of things. Like, can you be like can these agents help you configure your SDLC pipeline with just your intent in the natural language, right? Also help you discover like the state of the art in SDLC practices based on the usage they are seeing across the customers, and give you kind of the best in the world pipelines for you, right? Like so, those are the use cases we are looking at, um, right? So that's kind of where it is. Like ultimately, it's like with these agents available for you in SDLC lifecycle, what are the different scenarios we can take away the toil?
And I can relate to that as well because the work I did as a DevOps engineer before meant that if I run a pipeline, if something's wrong, I have to look at the pipeline logs, like download the log file and then do some sort of grep or some Linux commands to find out exactly where the issue is. Now, if my harness pipeline fails, there is harness AI. I can click a button and then that tells me exactly what the issue is with my pipeline. So one more ways how software delivery problems are being solved with AI.
Yeah, there you go, right? Like pipeline becomes yet another thing for you to maintain. Like you are changing some things, pipelines are always evolving. Can this agentic frameworks help you, like reason through that and figure out the things you're making a change in one place, what will be the impact on the pipeline if you're running in production, right? Um, so yeah, there's a lot of potential to bring this agentic AI capabilities.
So we're talking about AI. I think it's a nice segue to discuss future trends, where industry is moving. Based on your experience, like how do you see engineering teams balance the velocity? Because they have to incorporate AI, they have to incorporate the latest library, but they also have to be compliant. They also have to make sure that their software is secure. How have you managed to balance these two ends?
Yeah, that's a very interesting question, and jury is out there, like how things will evolve. One thing we definitely see is with all this AI agents and co-pilots, it has become a lot more easy for you to write a lot of code fast. Uh, but what for running a production system, it's not writing code is just one part of it. Like you have to make sure code is reliable and secure, right? And that's where we see more code doesn't necessarily make it more reliable and more secure. If at all, it becomes even harder to understand and maintain more the code you have. So that's where like the next level of unlock would be how can you bring this agentic AI or AI tools to also reason through the security of the code and reliability of the code. Like people are talking about like code documentation and test authoring of the code, and right, like all those are good signs. But ultimately, running the system in production, security, reliability is the key. And how do we? And with more and more code coming, I think there will be more need of having this AI systems help you make sure those are like the things are secure. That means what it means. Like if there are more checks in the pipeline to auto remediate the security issues, and uh, also figure out the, the reliability patterns. early on from your production systems and recommend what in your architecture is the weakness, and right, like, so there is a lot of systems engineering uh, which will need to come to the next level in the AI world. You know, coding is just one part of it.
For sure. So before there were a team of software engineers writing code, and then there were a few QA or testers. Now, with the influx of humans and machines writing code, do you see there's an imbalance of building code versus testing code? And if yes, do you see there's a potential gap for that in the future? And making sure we also have either more human testers or make sure that AI is also scaling our testing of the huge amount of code that machines are generating.
Yeah, I think it will be the case will be AI will be writing more tests as well, uh, right? And that's where like I think multi-agentic system where they can work with the coding agent and testing agent. I think that is the natural route it will be. But at the same time, it will be important for us to have uh, engineers who understand the code well. In case something like all these systems are still evolving, so if something goes wrong and you have a mission critical system, uh, you have to still be able to reason through root cause, fix the issues in production while you're gaining velocity. Um, the understandability and able to operate at production scale is still I have. Uh, I think there will be need for like more seasoned engineers who understand the basics of the system. That's where like system engineering running at scale with reliability comes in picture.
Shifting gears, I was told that you're into indoor climbing. Uh, would you like to tell our listeners and viewers about that? And a follow-up to that would be, how do you relate that to climbing corporate ladders?
Yeah, that's a good analogy. I don't know. So like if you think like I started like indoor climbing few years ago. One of my like few folks in my team at Microsoft, they used to do the indoor climbing, and like we as a group used to go. Uh, and that's where I picked up. And when but I paused for after I left Microsoft, um, and recently, few years ago, like I had a climbing gym near my home, and I started taking my daughter there, and that became like father-daughter activity for us, you know. And uh, and what I see is like climbing is like definitely uh, it you can go in the different parts, and obstacles could be different and keeps changing every few weeks, and then it keeps you interested. And um, also, you don't need too much prep for it. You just land there. The people just climbing. You need strength, and it becomes kind of an activity for me to do with my daughter. Um, so about the climbing ladder and all, I think you have to strategize there. Like there's a lot of like you need like strength and you need repetitions. You get better at it, but every time you change the course, you have to strategize from one place to other. Resilience is needed. You know, you learn resilience. You know, repetition helps you build the skills and muscle. uh, yeah, I think those things are anyways you can apply. You know, persistence. Sometimes you're tired, you give up, but you take a rest and you start again. Someday you can't reach uh, one obstacle course, and then you next time like, you come a few days later and you see like you have a different approach to do it. So I think those are the things that you learn, especially in the corporate ladder. I would say I don't know if it is like one to one, but corporate ladder is more like you end up taking more and more responsibility as you learn the systems and then people and processes, and you're able to reason through more how your work impacts the business, and more responsibility you can take. You can rally your people around the ideas which are important for business. Right, so that what I see. It's definitely uh, always learning where you are, and then kind of up leveling yourself to operate at the next level. And this is like continuous process. It's not like you reach the top and there's no top, like there's no ceiling there. Like you always. So that's where one of our culture at Harness is like continuously learn and keep getting better.
Very well said. When you're hiring engineers, do you look for specialists? Do you look for generalists? Or do you like T-shaped engineers, com-shaped engineers? Uh, what's your strategy for hiring engineering leaders?
For us, like here at Harness, have been like we have seen good success in hiring generalists, people who uh, are able to pick up and learn new things fast because the business keeps changing. Like when we started in 2017, 2018, what we were building versus what Harness is today in this AI native world. The only constant is like change, and you have to evolve yourself. And the core skills, analytical skills, able to problem solve, I think those are the, and then right minded people who can like learn new things fast and reason through the complexity and be analytical. I think that's kind of what I have seen more success. Um, but that's like there are some specialized cases where we have to look for people who have done that kind of things in past so they can build some context. So uh, but in general, by and large, I look for generalists who have really good analytical skills and have all the right learning growth mindset.
Totally agreed. Now, to wrap up, I was told that you're learning Spanish. Um, could you share with us some Spanish words that our listeners and viewers, me as well, I have Duolingo installed on my phone. I probably learned 10 French words, but that's it. So I'd love to learn some Spanish words from you.
Yeah, I think that's funny. Like I think Duolingo was another such thing. Like I had like started Spanish, and like they had this really good gamification and like ability to engage the users, and they have this system of streaks, they will say, and they'll help you track the streak. And I had 400 days streak at building my Spanish skills. So yeah, like I learned few words like hola amigos, como estás, and manzanos, hombre. These are the words which are like the first few uh, sessions, and you keep getting better at it. I think that I love the platform and the gamification aspect of it. And
There's a TED talk from Duolingo founder as well. I'll add a link to that talk in our podcast description, and where he explained the same things. These softwares, they put in tons of research into keeping users hooked onto their platform, and they use the same methodology to teach languages. So a more positive way, I guess, to keep users engaged on screens.
yeah, this is a good example of how tech and keeping the engaged for good use cases. There are a lot of examples where we are helping people waste their time, but this is one of them where this technology is helping people upskill themselves.
Absolutely. What would be your closing thoughts on engineers who are thinking of moving from IC into management? How did you move there? How did you make the switch? And what would be your suggestions for them?
Yeah, I think that's a good question. Like, so for me personally, it was more like I was the strongest IC in the team which I was in, and at time the team size increased, and there was an unnatural place you need a leader or manager to formally run the team day to day. So that was my foray, like, and that was in Azure, where I was the founding engineer for the team, and I was passionate about the uh, that the problem we were solving, and I was always kind of open to help other engineers in the team and unblock them and help them be more productive. And it was a very natural transition for me as the team grew in size, and the problem became a lot more significant to take up that role. Um, for IC to become manager, like if I think you have to look for some traits, like are you uh, in there for the right reasons, you enjoy working with people. It becomes like as a manager more about the team versus yourself. So first thing you have to learn is team success is your success, and you have to bring the opportunities to them, and you have to be able to connect the dots from business asks to individual contributions, and make sure team is able to come together for a larger objective. So if you enjoy working with people, if you care about others' success more than yours, I think you will be successful as a manager.
There you go. Whether you're climbing walls or whether you're building systems, you have to connect the dots. And of course, you have to find fun in the journey, because at the end, this is a journey. This was the season finale of season 3 of ShipTalk podcast. We had Puneet Saraswat, VP of Engineering at Harness. Thank you so much, Puneet.